examples involving arrangements and associated probability. Let us recall the rules that are associated with arrangements, and we start with the fundamental counting principle. This principle simply states that if there are m ways to do one thing and n ways to do the other thing, then there are m times n ways to do both things. Number two, rule for arranging a subset. Repetitions are not allowed. The rule simply states that if we have n different things taken r at a time, then we are saying the p is representing permutations. Then we are saying we are taking r things from n things, which is the same as n factorial over n minus r factorial. But at this point, we need to understand the values of n and r. That is, what do they stand for? The n and r are simply quantities. N is the number of items in a given set. R, again, is the number of items in a subset, right? Then number three, rule for arranging a subset, repetitions are allowed. The rule simply states that n things taken r at a time is the same as n to the power of r. Still, the n and r has the same meaning as I explained here. Number four, rule for arranging a word with no repeated letters, or repeated letters are treated as different and a letter used once, right? This rule only refers to when you are arranging the letters of a word with no repeated letters, or it will be stated that the repeated letters are treated as different. The word different would mean the letters that are repeating, you don't see them as repeating, you see them as different. So the rule states that any different things in any ways is the same as n factorial when you are arranging them. So here we are saying n, that is the quantity. So if I have 10 people to represent n and I want to put them in seats, that means I have to have also 10 seats, right? So the ways that I will arrange those 10 people would simply be 10 factorial. That's the meaning of this. Number five, rule for arranging a word with repeated letters. That is, it will also can be stated that repeated letters are treated as the same. So when you have a word with repeated letters, that means we have to recognize that they are there. So you then apply this rule, which states that n letters can be arranged where m1, m2 up to mn of the letters are identical. The word identical, you can substitute it with the word same. That means you'll be having these quantities representing letters that are the same. But then when you come to the rule, it simply says n factorial over m1 factorial times m2 factorial to mn. And the meaning should be the numerator is, we are saying the n letters that we have, right? We are going to consider that there are no repeating letters, so that we apply this rule, which is n factorial. So that is what we have at the top. After we have done that, then we start now to consider the repeating letters. For example, in the word repeated, I have 3 E's. That is, E is repeating 3 times. So my M1 will be equal to 3. Then I'll be saying the 3 letters, if I were to arrange them, I'm going to consider that they are different because they are going to occupy 3 different slots or places. Therefore, I arrange them in 3 factorial ways. So this is why then we then say M1 factorial. Then the same can be said for the other repeating letters. So it is important also to understand exactly what is taking place so that at the end, everything will be simple to deal with. Okay. Now, here's the problem. Consider the word advertisement, right? Our first task will be, we are required to find how many word arrangements can be made with this word if the repeated letters are treated as different letters. So the fact that we are going to regard or view the repeating letters as different, that means we are saying in the word advertisement, there is no repeating letter that is in A, right? Let's go on to B. How many word arrangements can be made with this word if the repeated letters are treated as identical? That means you are going to recognize that there are repeating letters in the word advertisement. So you see how we are going to treat that, right? Then C, how many word arrangements can be made with this word if the word starts and ends with the same letter, right? This is another situation. We'll see how we are going to approach it, right? We go on to D. What is the probability that the word starts and ends with the same letter? So you see that C and D, there is a relationship. You will see how we are going to treat them. Then E, how many word arrangements can be made with this word if the word starts with the letter M, right? That is clear. Then number F, what is the probability that the word ends with the letter M? Again, there is something common about E and F. So let us now give solutions to A to F. First, we start by analyzing the given word advertisement. How many letters does it have? There are 13 letters, and which letters are repeating? The E is repeating. That means we have 3 E's. The T is repeating, so we have 2 T's. Now, going to our first question, how many word arrangements can be made with this word if the repeated letters are treated as different letters? That means in the word advertisement, I don't see any repeating letter. There are 13 different letters. That is the meaning of treating repeating letters as different, right? So as such, you realize that the fact that we have 13 different letters, therefore we have 13 positions to fill, meaning the first position has 13 choices. Once it is filled, the second position has 12 choices. Once it's filled, the third position has 11 choices, and so on and so forth. So as such, now I have the row with 13 columns. The columns are representing positions. That means 13 positions. So what I've written here is what you can see now in the table, where in the first position, I have 13 letters to choose from. That means any of the 13 letters can occupy that position. Once it's filled, I'm left with 12 letters. Any of the 12 can fill this position. Once it's filled, I'm left with 11, and so on and so forth up to the last position, right? Now, these numbers as they are put, they are simply representing choices of different positions, right? So using the fundamental counting principle, all what it means is together we have to multiply each. That is 13 times 12 times 11 times 10 down to 1. And this can be shortened as 13 factorial. So this is all what it means. The possible arrangements is 13 factorial, and you have seen how it has come about. But all the same, maybe understanding that we are dealing with 13 different letters and different things in any ways. That means the 13 different letters were supposed to be positioned in 13 positions. So with that, then it simply means we are supposed to take the 13 and simply say 13 factorial. So this is the rule that you could have used directly. But otherwise, when I put things in a row and columns, it's for your understanding, so that by the time you actually dominate what is happening, you can go forward to simply apply this rule. Let us check on B. How many word arrangements can be made with this word if the repeated letters are treated as identical? So now we are saying in the word advertisement, we have to take note of the letters that are repeating, that is treating them as identical, right? So with that now, we need to understand that in this case, you first, that is the numerator for the rule that you are going to apply. The numerator, you arrange the given word, right, as if there is no repeating letter. That means 13 letters, 13 factorial over. Then you go on to check on the repeating letters. We have 3 E's. So the way we are going to arrange the 3 E's is 3 factorial. This is what we have here. Then times the 2 E's. The way we are going to arrange the 2 E's is 2 factorial. So this is the possible arrangement, and what is at play here is this rule. N letters can be arranged where M1, M2, M3, up to Mn of the letters are identical in this format. So that at this point, you should know that the M is simply telling us the quantity of the repeating letter. Like in our case, the E is having 3, right? So M1 is equals to 3. Then how we arrange those 3 letters is 3 factorial. This is why we have 3 factorial here. The same can be said to say M2, we go to the T. We have 2 T's, right? Therefore, M2 is equals to 2. Then the way we arrange those 2 letters is 2 factorial. This is why we have here. So this is the understanding that you should always have as you arrange a word with repeated letters, right? Okay, let us go on to C. How many word arrangements can be made with this word if the word starts and ends with the same letter? Right here, when you have a word starting with the given letter and ending with the same letter, then in the word advertisement, you only have to look at those letters that are repeating, that have more than one. You cannot look at A because the A is just alone, but we have the E and the T. We can have such situation where the word starts with the E and the end with the E, or start with the T and end with the T, right? So here's the situation, the 13 positions. Now I've put my E at the first and E at the last. And this is 1, 1. The E here, the E there, right? Then from there, this is one situation, isn't it? Now I can go for the other situation where now I'm saying, no, here I'm going to put a T and a T, right? So T at the first and T at the last. So I have a T here, a T there. So it's 1, 1, right? So all what it means here, we have 2 scenarios, 2 situations where we can have words, right? Starting with E, ending with E. Or we can have words starting with T, ending with the T, which is the condition that we have in this problem. Therefore, once I've done this, all what I need to do now is, if the first position we have an E, the last an E, how many letters are left? That means I've used 2 letters. From 13, I have 11. So the 11 have to be placed in these 11 positions, right? So that being the case, remember we are placing the what? The word, the letters in the positions. So in such a case, first, this second position, I have 11 letters that can be placed here. That means I have 11 choices. Once it's filled, I go to third position, 10. Once it's filled, 9, and so on up to 1, right? Okay, this is how we can fill the other 11 positions. Be the case that we have the E ending E starting, or the T ending T starting. The other 11 positions are filled in this manner. But let us understand something. If we are considering the situation where we have the E starting and the ending, right? Then those E's are removed and I'm remaining with only one E, right? But the T's are still there and they are repeating, right? So we are simply saying 11 letters left to position or place. To do that now, to place, right, in the case we have the E and E, to place the 11, right, you should make sure that you place the 11 letters, then consider the repeating letters, that is the 2 T's, right? This is why then we are saying 2 factorial. So the arrangement of the 11 letters after we have positioned the E's in the first and last is this, right? Or if it is the situation of the T starting and ending, then it means the T's are no longer there in the word advertisement, but the E's are still there, right? Then we have 11 letters left to position or place, right? But how we position the 11 letters as if we don't have any repeating letter, that is the 11 factorial. Then we consider the repeating letters that we have 3 E's, so over 3 factorial, right? I'm simply reasoning from the rule that I showed you, that is rule number 5, where we have a word with repeating letters. How are you going to approach this? This is what I'm doing here. So this is what makes me have here in the case of the E and E. Then in the case of the T, that is T here, T there, we have 3 E's repeating. So 3 factorial dividing the 11 factorial, right? Now, once this is done, what it means now is we wanted to find it together the 2 situations. We have the E is one situation, the T is another situation. So we are saying E or T as in situation. So together we are saying now, if I consider my E to say is the first and last, then I'm saying 1 times 11 times 10 times 9, but the 11 to 1 is 11 factorial. So it will be 1 times 11 factorial, right? But this 11 factorial is divided by 2 because we still have the 2 T's. So it's 1 times 11 factorial over 2 factorial times 1. That is the situation where we have the E's in the first and last position. Then the OR part, then it's plus. Then we have 1 times 11 factorial over 3 factorial, which is this one, plus times rather 1, which is the last one, right? Then when we simplify this, we end up with 11 factorial over 2 factorial plus 11 factorial over 3 factorial. We can leave it like this or get this number as it were. But what is important, or the silly mistake that one can fall into, the issue that we have 3 E's. When you consider to say this position, it's just a position where if you put n of the E, it's an E. So you don't consider as if you have 3 choices. No, a choice can be there where we have more than one different things. Then you can choose the other one or the other, but here there are just 3 E's. So there is no any other thing that you can talk of choosing. So we simply put the E there and it's 1. Then the other E at the end. The same can be said with the T, right? You cannot choose from the same things. No, it's just the same. There is no choosing there. So be very careful on that. So once we have arrived at our possible arrangements, so this is the solution to C. Going forward, let us now go to D. What is the probability that the word starts and ends with the same letter? Already in C, you have seen how we calculated the possible outcome of a situation of having words that start and end with the same letter. So, of course, you know that the fact that we are talking of probability is a fraction between 0 and 1, right? Its numerator is occupied by the favorable outcomes, and the denominator is occupied by the possible outcomes. So looking at this word advertisement, if we were simply to arrange the letters, we have to take note of the repeating letters, right? So the possible arrangements or outcomes, that is set S, it will be the 13 letters we have, 13 factorial over the repeating 3, which is 3 factorial times 2 factorial. That's the possible outcome. This is what you should always know, that if you are given any word, if you are to arrange it, if there are no repeating letters, then it's simply the number of letters factorial. If there are repeating letters, you make sure that the numerator is the number of letters factorial over the letters that are repeating. This is important because at times, remember, these problems, when they come, they can talk of repeating letters. How are you supposed to treat them? But in the case you're given just a way to say, arrange this word, obviously you have to take into consideration the repeating letters, right? And that is the normal thing to do. Okay, now finding the favorable outcomes, set F. Obviously, we have seen already this in C. This is the figure that we got. So the fact that now we have our sample space and the favorable outcomes, now to find the probability that the word starts and ends with the same letter is number of items in set F, our favorable, over the number of items in set S, our possible outcomes. So we have this to represent this. Instead of drawing a line, I've substituted this line by the division sign because it means division. So this number divided by the possible outcome is a fraction, like that. Then you can then simplify this to 2 over 39. So that's the answer to D. Okay, going forward. E, how many word arrangements can be made with this word if the word starts with the letter M? I think this is a very simple situation, and all what we need to do is to come up with the 13 positions, and we are saying the word should start with an M. We have placed our M is there, that is the M first position. So we subtract from 13, we are left with 12. So to fill the other 12 positions, all what we need to do is, we need then to first understand to say in the word advertisement, already the M is no longer there. We have removed it, but we have the E is repeating, the T is repeating. So 12 letters left to occupy the other 12 positions after positioning M. So what does that mean? we are simply saying the second position, n of the 12 letters can occupy that. Once it's occupied, 11 left for the third, and so on up to the last one, right? But remember, we want how many words, arrangements, right? So the thing now is, if we are to then give a solution to that, we are not going to ignore the repeating letters. So the possible arrangements start with the letter M. Or what it means is 1 times 12 times 11 up to times 1, which is what I have here. Then we then consider the repeating letters, 3 E's, 2 T's, which is what I have here. Dividing after applying the fundamental counting principle is the one that allowed us to multiply, as you can see, right? Then simplified at first, this 12 times 11 times 10 up to 1 is 12 factorial. This is the one which is here. Then at the bottom is still the same. Then obviously 1 times 12 factorial is 12 factorial over that. You can simplify or you can leave it like that. So this is the solution to E, and this is the approach. Never ever forget to pay attention to the repeating letters. Even if you have done it like this, this is very correct. But when you come to write the answer, you then have take note of the repeating letters like I did here. Okay. Of course, maybe I've already said it, but I'm saying it is important for you to note that the fact that nothing is specified about repeating letters in the word advertisement, we have to consider those repeating letters because elements of sets do not repeat. That is why we divide by 3 factorial times 2 factorial. I think I've already explained. This is all what it means. Unless if something was said to do with the repeating letters in the word advertisement, but nothing was said. So the normal thing to do is when you arrange it, you have to consider the repeating letters. If you didn't have repeating letters, then it was simply going to be the multiplication of that and you are done. Okay, let us go to F. What is the probability that the word ends with the letter M? Already, previously, we have found in how many ways we can arrange the letters of the word advertisement, taking into consideration that each word ends, or I mean, start with the letter M, but here we are saying ends with the letter M, of which is still one and the same thing. Whether it starts with the letter M or ends with the letter M, M is going to occupy one position. So we simply proceed as we did previously. But before that, the fact that we want probability, so we need to come up with the possible arrangement, that is the possible outcomes, of which if you are to arrange this word advertisement, 13 letters, that is 13 factorial, right? Then you divide by the repeating letters, 3 E's, 2 T's, their arrangement is what is on the bottom, right? Then this is how it should be. Like I've already referred to E to say we had to come up where the words start with an M. You would see that now it's ending with an M, which is one and the same thing. The favorable outcomes then becomes 12 factorial over 3 factorial times 2 factorial. If you don't understand how this is arrived at, it is the same approach or explanation that I gave in E, because it's only the position, but otherwise after positioning M here, you still have 12 slots to fill. And besides, after removing M in this word advertisement, you have the 3 E's and 2 T's. which is what is on the bottom. So for the probability that the word ends with the letter M, then our favorable outcome is this one. This occupies the numerator, and this occupies the denominator, the possible outcomes. So we are saying number of favorable outcomes over the possible outcomes, which is favorable is this, which you see here, divided by this, which is the fraction, which you see here. Then from there, you can now substitute the division by a multiplication sign. But the effect of doing that, you have also to substitute the divisor by its reciprocal or inverse. That means the denominator will be the numerator and the numerator will be the denominator once you change the division into multiplication sign. Simplified, this will reduce to 1/13, right? So that's the answer to F.